Right, so question number 2. Again, so I don't know whether I have discussed this before. I will say yes, 2011. Please go through it. It's typically very similar one, but little bit different. So element A belongs to S block. So quickly, what are the S block elements? You have lithium, you have sodium, potassium. So you have lithium, you have sodium, you have potassium, and you have what else? Cesium. And typically we will consider about this. Let's without going to francium and those things. So here it belongs to S block and its first ionization is highest in the group. So from this 4, which one has the highest first ionization? You know, when you go down the group, the number of shells are increasing. So the distance between the nucleus to the outermost electron is getting larger and larger, which typically means when you go down the group, the first ionization energy decreases, which means this element automatically should be lithium. No other option. So by reading the first statement, you should be able to understand this is lithium. That's it. Okay. So the element A, so it is lithium. Now we will go to the rest of the question. It reacts with water liberating B gas. So you know lithium, when it reacts with water, it forms lithium hydroxide and hydrogen gas. So here they are talking about this hydrogen gas. The resulted solution from this reaction gives a red coloration to the Bunsen burner. So automatically this confirms our conclusion of the first statement. Normally, when you consider about the flame test, if you don't know, please go through the cation analysis video. I have already mentioned this before many times. So red, normally there are 2. One is strontium and one is lithium. So lithium normally give the red color and strontium, but here strontium belongs to group 2, not for the group 1. So automatically this becomes lithium. And Bunsen burner and the metal oxide on evaporation. So this gives a metal oxide, typically lithium oxide, right? And they further tells that A reacts with nitrogen. So A means lithium to give compound C. So you know when lithium is reacted with nitrogen, it forms Li3N, right? So there is nitride. If you can remember nitride, where do we discuss? The reaction of A with H2 gives a salt-like basic compound. So typically it is lithium hydride, right? On treatment of H2O, C. Now what is C? C is this lithium nitride. So when you treat this one with water, they say, okay, when you treat this one with water, E gas is formed, which turns red litmus blue. So red litmus blue means, typically you can easily remember like this, BRB. What is BRB? A base will turn red litmus into blue. That is what BRB means. A base will turn red litmus into blue. So this turns red litmus into blue means gas E is basic. But you don't need to at least know about that, because if you can remember about the ions that we discussed that gives gases with water, this is N3 minus ion, right? So N3 minus ions with water, if you can remember, it will give ammonia gas, right? So if you know about your analysis really well, this will not take much time to complete this question, right? So first one, identify A, B, C, D, E. So A is lithium, B is the liberated gas, hydrogen, C is the compound that form with reacting with nitrogen. So it is lithium nitride. And D is the basic compound, which is lithium hydride. And on treatment with H2O, C gives E. So E is ammonia. So you know all the compounds here automatically. Then you need to give the balanced chemical equation. So the idea is, you can see they have expected 5 reactions. So you need to write down all. First one is it react with water. So lithium plus water, lithium hydroxide plus hydrogen, the first reaction. The second reaction is, let's say it reacts with nitrogen to form LiN3. This is one of the reaction that you need to react. And it reacts with hydrogen to form LiH. And when Li3N is reacted with water, it gives the ammonia. So lithium hydroxide and ammonia is formed. This is another reaction. So what else the reaction is missing here? That is the formation of the oxide, metal oxide. So metal oxide formation means you have lithium hydroxide which forms with water, and when you heat it, it will form Li2O, right? So typically, if I stop sharing, so according to the reactions that is given, basically you will have so first thing is it reacts with water, right? Forming lithium hydroxide plus H2. Okay. So put the conditions, the physical states, and you need to balance. So the second one is you heat LiOH to give Li2O plus water. Then lithium plus nitrogen into, it will form Li3N. And then Li3N with water, again it will form LiOH plus ammonia. So there are 1, 2, 3, 4. So what is the other one? One of the reactions they have asked. Let's see, that is given. Yeah, it is the lithium with hydrogen, which form LiH. So you have the 5 reactions that is asked, and you need to balance that all. That is all, right? So if you know these reactions, that is totally fine, right? Water, the decomposition of hydroxides. So remember, not only lithium, when you have magnesium hydroxide, calcium hydroxide, all will give the typical oxide of it, except the ones that are very below in the structure. For an example, if you have like, let's say, yeah, silver, maybe AgOH, or even Pb OH twice. So still, when you heat AgOH, it will give first Ag2O. But Ag2O, the elements in the below of the electrochemical series, you know, they are very less reactive. So even when you keep in the heating process, so first AgOH will give Ag2O, but this will further decompose into Ag plus oxygen to the element, because this reaction is not favorable. So it quickly tries to decompose very fast. Okay. So this is not belongs to this question, but typically you should know, like silver and yeah, not lead basically, and the elements that we have on the below, mercury and silver. Typically mercury and silver, they tries to form its elements. Like lead hydroxide, it will form PbO physically, and it can be maybe also form the oxide with high heating. It will might form the element. Okay, but typically I will share the screen again here. No questions up to now, right? So you have written down, I have written down all the reaction that is belongs to this particular questions. And remember, their remark is, if A is wrong, all are wrong. No point in deciding the compound here, E. as well. Okay, so remember about silver and mercury. Okay, these two are very less reactive elements, and typically most of the elements above, if you decompose their hydroxides, more or less it will give their oxide. So when you have hydroxides of these two elements, still when you decompose, it will give the relevant oxide. That is the first point. But these oxides are, their oxides are not stable, which means you are heating it, it will decompose into its element plus oxygen. Okay. So following questions are based on the transition metals, so vanadium and chromium and their compounds. So you can give the ground state electronic configuration. This is straightforward. And you know the positive oxidation state, +2, +3, +4, +5. So these are the common ones that we have already seen before. Chemical formula of the oxides formed by vanadium. So indicate their acidic, amphoteric, and basic nature. So I think I have given you or discussed you in one of the MCQ papers as well. So I will again share one of the, let's see, yeah, it's here. So this is vanadium, right? So if you went through my D block chemistry video tutorial, you should know now, up to now, okay? So typically it has these oxidation states, right? +2, +3, +4, +5. And you should know the reactions. And these are the compounds, the oxo ions, and these are the compounds it forms in water, and the oxo cations, right? And in this particular question, they are asking about this. So I have already told you in previous cases also. You just need to remember about VO2. Why? Because it is amphoteric. Okay. So if you know VO2, the other oxide that will form, this is because we got +4, it will be +5, high oxidation state, which will be acidic. I told you, when the oxidation numbers increases, it becomes more acidic. When it decreases, it becomes both basic, right? So if you know VO2, which is amphoteric, V2O5 will be acidic. And the less oxidation state is +3 and +2, which will be V2O3 and VO, which should be basic. So you know all this according to that, right? And I'm going to explain further about this one because all those are related to this particular question. So then they have as titanium and vanadium are generally stable, but when you have high heating, it will form titanium oxide and V2O5. Then here we have chromium because they have asked something about chromium as well. So it is very good to think about chromium as well. So chromium, you can see typically it forms chromium 2+, which is blue in color, but in presence of air, it can quickly oxidize to purple. Okay. So these are one of the three ions that will form chromium in solution when you have chloride or sulfate with different colors. The importance of this part is because they have also asked about a little bit about chromium, where if you have chromium 3+ in a solution which forms from dichromate, this question is directly, this entire thing is directly asked in a question. See, if you have acidic medium H2O2, when you add dichromate, this H2O2 is added. What is happening here? Chromium 3+ is formed at the end. Okay. And if you add H2O2 at basic medium to this chromium 3+, it will form the chromate, which is yellow in color. So typically this is the equation. So if you know all these reactions typically, which gives you the idea, you know most of the reaction of this compound, then you have manganese and all those things. Now we will come to the question now, because this is the necessary part that we should discuss about the question. So now you know the positive oxidation states of vanadium, and give the chemical formula of oxide formed by vanadium in the positive oxidation states given above, and indicate whether each of these oxide is acidic, amphoteric, or basic. So typically VO, V2O3, VO2, and V2O5, plus 2, plus 3, plus 4, plus 5. So you should know because it is already mentioned. So write the chemical formula of the two oxocations. So again, I have mentioned there VO2 plus and VO2 plus, VO2 plus, this is one, the other one can be, you can write VO2 plus, right? And their colors. So you know here VO2 plus is +5, which should be yellow. And here VO2 plus means +4, okay, which is typically blue. So yellow and blue. So these are very straightforward if you know your theory really well. So the idea is, I always tell, please go through these videos. You can have a comprehensive knowledge, and that is very important. What is the simplest ion that chromium forms in aqueous solution? So you can understand about chromium that I have discussed before. Where is it? I will again stop sharing and share that particular one so you can understand. Okay, so chromium, what is the typical ion that chromium forms? So chromium in the presence of diluted H2O, SO4 and HCl, it will form chromium 2 plus. But you should understand chromium 2 plus in the presence of air, it will form the chromium 3 plus. So typically it is the chromium 3 plus ion that is going to form, right? So I will share again. So it is the chromium H2O6 3 plus ion that is going to form. So its color is purple in color or violet. Predict what would you expect to observe when solid sodium carbonate is added to an aqueous solution of this. So chromium in the +3 state, when you add little bit of sodium carbonate, which is typically a basic salt, if you can remember, what will happen? This basic salt will precipitate out the chromium 3 plus. So chromium hydroxide, right? CrOH thrice will form. So CrOH thrice is typically greenish in color, right? This is what going to happen. So what would you expect to observe? This sodium carbonate will form a greenish color precipitate will form, or either because of this basic compound that forms the precipitate, which replaces water, which means it will form H2CO3, which will decompose to carbon dioxide and water. So you can explain it that as well, like formation of bubbles. You will observe bubbling, right? How this bubbling is observed? Because when you add this sodium carbonate, which is little bit of basic into aqueous solution, H2CO3 is formed, right? Little bit of H2CO3 is formed. So you can see bubbles form. So give one use of metal V. So always when you ask about use of metals, typically we say it is used in the production of alloy, right? That is one of the answers that is possible. The other answer that I am normally trying to explain to you, write down, that is like the vanadium catalyst, right? So if you remember about V2O5, if you remember about V2O5, it is used as a catalyst in sulfuric acid production, right? So it is typically used in sulfuric acid production. So this you should know. And if you write this one, it is better. The answer that you write, vanadium is used, typically used for alloy, is enough, but try to be more precise and more accurate, okay? So this is about the vanadium question. So this is about vanadium. They have asked about vanadium. See, they have even touched the D block as well here. Okay, inorganic stuff. And then they are going to chromium. So what would you observe when a green colored chromium is subject to the following? Okay, so when you have chromium 3+, so let me see if you have any questions up to now. No, if you have any questions, please put here. Okay, so when you have chromium and if you put little bit of yeah, here also they ask about chromiums, right? Okay, so when you add a little bit of chromium chloride and you add a little bit of dilute, this is important, dilute NaOH, what will happen? It will form the chromic hydroxide precipitate, which is greenish in color. Because why they have mentioned it dilute? So this is also important. So we will quickly go back again to our screen. So if you go through the video tutorial, it will be very easy for me to quickly go through it, right? So you can see here, addition of aqueous ammonia or aqueous NaOH, which means typically the dilute NaOH, it will form this dirty color green precipitate chromium hydroxide, right? But remember, if you add concentrated or excess, this chromic hydroxide will further dissolve and form dark green color, typically CrOH63-. This is very important to know. Okay. And think about this as well, because it is asked in the question. Adding H2O2 in the acidic medium to dichromate, which form green color chromium 3+, after forming an unstable intermediate, which is blue in color. So when you add acidic medium H2O2 to dichromate, it will form green color chromium 3+. And in the basic medium, if you add H2O2 with the presence of OH-, which is the basic media, it will form chromate, which is typically yellow in color, right? So now you can see what is going to happen. Addition of few drops of H2 NaOH. So I told you this will form chromic hydroxide, right? So this will form the chromic hydroxide, typically forming the chromic hydroxide, CrOH thrice, which is greenish in color, right? Addition of excess dilute NaOH, which will form the CrOH63-, followed by H2O2. So if you can remember, in the presence of OH-, chromium 3+ with H2O2, now you remember, I have explained to you what is forming in the solution. What is forming in the solution? It will form CrO4(2-), which means a yellow color solution is formed, right? This is the reaction. I will again show you. See, chromium 3+ in the presence of excess OH-, in the presence of H2O2, which form the chromate. Okay, so this is an important reaction. That is why I have put answer, the star mark, right? This is very important to know. Right, so these two are very straightforward again. If you know your D block, it will not take like 1 minute to at least to complete this one. You can answer very quickly. Then we have, when a concentrated solution of dichromate is treated with H2SO4, okay, we are treating this with H2SO4, a bright red acidic oxide of chromium is formed. So if you remember about your acidic oxide of chromium, according to this situation, you should automatically think. You should know now, up to now, okay, if you know about chromium. And on heating X, okay, they are going to heat X. A green amphoteric oxide is also given. Why? And Y also could be obtained on heating ammonium dichromate. So if you remember about our decomposition of ammonium salt, I have given you the decomposition of ammonium dichromate. So if you decompose this one, ammonium dichromate, it will form nitrogen into Cr2O3 plus water. Right? So if you don't remember, I will again, I will show you. First, I have to go to my inorganic notes. Where is it? Analysis, I guess. I will share this again. So I have already given you this tutorial. So these are the decomposition of ammonium salts. And here, see, I have given ammonium dichromate. When you decompose, nitrogen, Cr2O3 and water is formed. So only few ammonium salts that you normally typically should know, right? So Cr2O3 is formed. This is one that you should know. Second is, where is it? About chromium. So if you go through chromium really well, so you can see what are the amphoteric oxides. So Cr2O3, we already knew this should be the amphoteric one, because when ammonium dichromate is heated, it will form Cr2O3. That is one factor. Okay. And you can imagine what should be the acidic one. Here it is already given. And if you know these things, again, I would say you will not get some time spent to do this question, right? Okay, so what is this bright red acidic oxide? So typically, if you know about your chromium chemistry really well, it should be CrO3. Okay. And on heating X, so green amphoteric oxide is this one, Cr2O3, which is Y here. And Y also could be obtained by heating this one. So what you have to do here is you have to just think about the reactions that is happening. And if you don't know the reactions that I have mentioned here, please go through the D block tutorial, because you can automatically get all these questions and all these explanation clearly. The idea is there. At least you don't need to go to the D blocks chemistry tutorial. Just write down those equations quickly and keep it with you, and you should know those things, right? And so you know now X and Y. And what would you observe when dilute NaOH is added to Cr2O7 2-? So this is another one that you should know here. So I will show you here, because this is very important. Okay. So this was H2O2 for dichromate in acidic medium. Now here they are asking about Cr2O7. They are adding a little bit of NaOH. So always remember about this thing. Please remember this equilibrium, which means always remember in aqueous water solution, dichromate and chromate is always in an equilibrium. This is the first point that you should know. Dichromate and chromate is always in equilibrium, right? So if you know this equilibrium, you can answer, because think about this, right? When dichromate is dissociated in water, it will form chromate and 2 H+ ions, right? Now think, in the question, they have asked, you are adding a little bit of NaOH to dichromate. So if you have NaOH in the solution, which means this H+ is removed, right? So H+ react with the OH- in the solution, and this equilibrium will be shifted towards the right-hand side, which means the amount of dichromate will be converted to chromate, which is now yellow color in the solution. So typically, although this is related to adding barium chloride to this solution. Don't forget, this is forming the precipitate from this equilibrium to this equilibrium. Then automatically this equilibrium is shifted. In a similar way, if you add little bit of basic, this H plus will be removed. That is what it is asked in the question. So if you have NaOH, this equilibrium will be shifted towards the right hand side and yellow color solution is formed, right? So again, I will stop the. So what would you observe when you add a little bit of diluted NaOH to the dichromate solution? So you can typically quickly write down the observation directly, or you can small the equilibrium, and you can say equilibrium will be shifted to right hand side forming yellow color solution. That's it. Okay. Or you can, they have only asked about the observation, so you can yellow color solution is formed. What is the typical color of dichromate? It is red in color. Cr2O72- is red in color. But CrO42- is yellow in color. But when you add little bit of Cr2O72-, you always see yellow color. Can someone tell me why? So I am posting this question to you. Cr2O72- is red in color. Okay. CrO42- is yellow in color. Okay, red means orange. You can take orange as well. Okay, a little bit red in color. Now I am asking, if you put Cr2O72- into water, little bit of water, it quickly turns into yellow color. I am asking why. Can you explain based on that equilibrium? If you want, I can show you the equilibrium as well. So this is the equilibrium. Can you think about it? So I am waiting for your responses. What I am asking here, if you add little bit of dichromate that is given in this equilibrium to water, you will automatically see chromate ions forming, the yellow color solution. I am asking, what would you think why it is formed like this? Can you explain that? Because in the solution, there is dichromate and chromate. So red and yellow, it should be like forming an orange solution. But typically you observe chromate. What would you think about that? So just say, can you explain it or not? Yes or no, at least, because I need response from your side. Otherwise, I'm just like talking to the screen itself. So please try to answer my questions. Can you explain or not? Yes or no? So Kimutu says no. So what about others? So just think about this reaction. At least others, you can say yes or no very quickly, because this is for just to check whether you are in the track or not. Otherwise, I am just explaining to the screen. Or the person that is just looking at me. So can you explain it based on that? Okay, I have another answer. No. What about others? Okay, that's good. So the idea is this. So when you add this to water, typically dichromate, you see yellow color solution. Why? First thing is this equilibrium exists in water. That is one. This equilibrium exists in water, which means when you add a little bit of dichromate to water, you can see it reacts with water. Chromate, chromate, and H+, right? So this is the idea. So typically in water, when you have this equilibrium, which means these two ions should be present in the system. That is one idea. But why it is showing more yellowish color in the solution is, remember, normally the water that we use in our laboratories as well as in our taps, mostly they are a little bit basic in nature. Little bit basic. The pH is not 7. It will be a little bit higher at 25 degrees Celsius. Which means it is like a little bit of basic in nature means little bit of NaOH. So which means when you compare about the equilibrium, there will be more chromate ions in the solution than dichromate in the solution, which typically gives dominant color of chromate. For an example, if you think about the equilibrium, there will be 100 molecules, 100 ions of chromate in the solution when you have one dichromate in the equilibrium. You can understand, according to the Le Chatelier's principle, the equilibrium is shifted towards the right-hand side in water. That is why you observe this chromate color, not dichromate. Okay, so did you understand that? Did you all understood that? It forms yellow color. Why? Because this equilibrium is more shifted towards the right-hand side in water. That is all. You can answer very simply. That's it. Okay. So I will stop sharing again for this particular one. So this is what they have observed. You can just directly answer a yellow color solution is formed, right? So the last one is give one advantage and disadvantage of K2Cr2O7. This is potassium dichromate. So if you can remember, I have told you this in many cases. K2Cr2O7 is a primary standard. So you can use this as a primary standard in titrations. Okay, that is the advantage. Or even you can say one advantage is this, you can use as a oxidizing agent. Because here it is +6, it can be reduced to +3. The idea is if this can be get reduced to +3, the other compound should be oxidized. So it is used as a oxidizing agent. And the typical disadvantage in titration is when you use this as a solution in the medium, you cannot use this as a self-indicator. Okay, so what is a self-indicator? I will explain that to you using the board, right? So the typical idea of a self-indicator is, now let's say you have MnO4- as your oxidizing agent. In acidic medium, MnO4- turns to Mn2+, which means this purple color will be more or less going to colorless. Very pale pink means typically you can observe it as a colorless solution. So the idea is, if you use MnO4- in a titration, when MnO4- is consuming in the titration flask, for an example, at the end point, where you have consumed all MnO4-, if the other compound is colorless, more or less, this will becomes the end point. Because for an example, let's say you have MnO4- here, and you are, let's say, titrating with a compound like, for For an example, like colorless metal, for an example. Okay. So when you add, according to the redox reaction, this MnO4 minus will consume, and at the end where all these MnO4 minus is finished, your color change will be purple to colorless. Okay. But when you use K2Cr2O7, there is an initial color. If the solution is little bit basic, it will be yellow. If the solution is little bit acidic, it will be more or less red in color. And in the acidic medium, it will be converted to chromium 3+. And here it is green in color. Which means here MnO4 minus can be taken as a self-indicator to find the endpoint because it goes from purple to colorless. You can easily find the endpoint. But when you have dichromate in the solution, it will go from like a yellowish color solution to green in color solution. So you can tell, okay, the endpoint can be maybe obtained when you see green color in the solution. But the problem is you cannot exactly detect by your naked eye the color change from yellow to green. So it is a problem. Therefore, you cannot do this titration very directly using only K2Cr2O7. Here you don't need other indicators to be added to the flask. You can use MnO4 minus as a self-indicator. But here you need some other compounds. For an example, if you are titrating with Fe2+, okay, here you cannot detect the color change very quickly, very straightforward. So what you do is, in the presence of titration of this Fe2+ with dichromate, we typically use diphenyl amine indicator. Because if you use diphenyl amine indicator, it will give a nice color change based on the indicator. But here in this one, you don't need to use because MnO4 minus itself will give a color change. Okay. Right. So the disadvantage is it will interfere with the color changes and cannot be used as a self-indicator. Okay. That is one of the disadvantages of this. The advantage is